My name's Violet Tembo. I'm a student at Northern Technical College doing my diploma. Today I will be explaining how a relay works in a circuit and how a relay works, its components and its makeup. So with me today I'll be using electronics board. This is my board, and these right here are my components that I'll be using. This here is my power source, and this is working as my step down transformer. It's a 250 volts, but our electronics board only allows us to use 12 volts, so it's a step down transformer from 250 volts to 12 volts. This here is what I'm going to use as my power source. From my power source here, it will come here. So this is what's going to get in first. And as you can see, this side is my negative side, and this is my positive side. So as I explain further, I'll come back to this to explain how the positive and negative sides work. So this is going to go in first. Then from here, these are my connectors, just for me to complete my circuit. This here is my fuse. A fuse protects the circuit. In case of anything, the fuse will blow first. So if there's no fuse in the circuit, we are at higher risk of having damage to our components in the circuit. So our fuse goes in next. Then from the fuse, this is my switch. This switch here will come here because it's the one that when we put it here like that, meaning we've closed the circuit, then current will pass through. But if we let it like that, then current cannot pass through. Then here we have our relay, our main topic of discussion. As you can see here, a relay has got two components in it. And a relay is electrically operated. When current from a source or in a circuit comes to our relay, here we have a coil. This box here you can see is our coil, and this on the top part is our switch. These are inside our relay. So what happens is when current comes through, it enters our relay, it comes to our coil first. From the coil, when it enters the coil, there's electromagnetic fields that are created. The electromagnetic fields that are created are going to attract the switch that's inside the relay. When it attracts them, it will close. Like I explained earlier with our switch that is outside our circuit, this one is an internal switch in a relay. And like you can see, it's open. So when electromagnetic fields are created, it attracts the switch and it will close. When that switch closes, that's when whatever source we have will go on. This here, as you can see, is our horn. And if you remember, I said our source here has got the negative and the positive side. With our horn, we've got the positive here and the negative. If I interchange this, our horn is not going to sound. So it has to be positive to positive. So I'll put this here. This is positive, and on my source here it's positive, but we need our circuit to be complete. So I'll get more of my connectors to complete my circuit. Right now we can say it's partially complete because as you can see, this one, it's from the source, comes like this and back. Starting from the fuse, comes there, then back to the source. But this side, we don't have something coming back to the source. Then we incorporate our probe. It's going to complete our circuit like the connectors this side. And if you've noticed on my relay, this switch here is not on the other side. Reason being, if we interchange the relay again, our switch here will not be able to it's not going to work this side because we don't have a load this side. But like it is, our switch has to come and switch on our horn here. So as it stands, our circuit is complete, and right now we can say it's safe to say we've got two circuits. There's this circuit that comes from our source to the fuse, the switch, the coil, and back to the source. Then we've got another circuit from the source, the fuse, switch. When the coil is energized, like I said, it's going to contact the switch. Then we have this circuit to the horn and back to the source. So since our circuit is complete, I'm going to connect my step-down transformer and connect our power source. Right now, as it stands, there's no current flowing through the circuit. So immediately, I'm going to close my switch here. You hear the horn sound. Reason being, like I explained, the coil will get energized, there are magnetic fields created, then the switch in the coil, in the relay, is going to close. But that only happens in a matter of seconds. That it will be like it's a 1-to-1 ratio from my external switch and my internal switch that's in the relay. So immediately I do that, you've seen my horn has gone on. If I open the switch, it goes off like that. So this happens in a matter of seconds, such that everything, the current going through the relay, you cannot even notice it if you do not know how the relay works. But like I've explained, the electromagnetic fields, the coil, the switch, everything works like a 1-to-1 ratio in our relay and in our circuit. So that was a brief demonstration on how a relay works in a circuit. Thank you very much.